Fourth assignment, skills practice. Lots of math formulas in this one. Okay, skills practice. Simple interest is an example of, it's A. Actually, it's A or C. Either one's okay. In the back of the book says so. And the reason why is because simple interest, it's linear or constant because your account grows by the same amount of money each year. So if I earn $3 interest one year, I'm going to earn $3 interest every year no matter how much I put in. It always goes off your original deposit. Okay, number 2. If a savings account pays 3% simple annual interest, a deposit of $250 will earn how much money in 2 years? Simple interest is principal times rate times time. So the principal is $250. The rate is 3%, so 0.03, and the time is 2. So I multiply that, and it's asking for the interest, okay? So it's $15. Your new balance would be $265, but its interest always goes back to $250. Even though you'd have $265, it always goes back to $250. So every year I'm earning $15. Okay, number 3. Which of the following pays more interest? Continuously always pays more interest than anything else, okay? The reason why is because annually means it earns interest once a year. Monthly means 12 times a year, so monthly is going to be higher than annually, but continuously means it's earning the 6% interest every nanosecond, pretty much. We'll talk more about that later, okay? Number 4. If a bond matures in 3 years and it's going to pay $10,000 at the time, the fair value of it today is, so I'm putting money in today, and then at the end of 3 years, it's going to pay out $10,000. I need to go back in time to find out how much it is. And there's a formula for that. It's A, that's what it's worth at the end, and then 1 plus R and then to the T power, the number of years, okay? So A, we have $10,000, 1 plus, and then your rate for that is going to be 6%, so 0.06. And then they're saying 3 years, so to the 3rd power. Now, these scientific calculators are really the only way to go to not have this take forever. So divided by parentheses 1 plus 0.06 to the power of 3. $8,396.19. Okay, next up, number 5. If a single deposit is made into a compound interest certificate of deposit, the account is, it's C. Okay, compound interest means it earns more interest every period because you're earning interest on interest. So I'm going to write that down. Earning interest on interest. So unlike simple interest where we're earning the same amount every year, in compound interest is 55's added on to 250. So now we're at 265, and then I apply the 3% to 265 rather than back to 250. Okay, so that's how that works. Number 6, $800 invested for 1 year at 6% compound quarterly. The amount of interest is, here's your compound formula. A equals P, the principal, that's my deposit, 1 plus the rate, and then N is how frequently the interest is added, and then N again to the N time N, the power is the product of N and T. So I just throw some numbers in. So we did $800, 1 plus our interest rate of 6%. Now quarterly means 4 times a year. So N is 4, and then 4, and then how many years? It's just 1. Okay, if it doesn't say how many years it's won. So we throw that in our calculator. So 800, 1 plus 0.06 divided by 4 to the power of 4 gives me $849.09. Okay, number 7. Okay. An 18% annual rate on a credit card balance. The answer is B. It's a nominal loan. It's nominal, and the reason it's nominal, any kind of loan is what we call nominal. When you run up credit card bills, that's a loan, okay? Okay, number 8. Deposit $1,000 at 6.2 simple interest, the balance after 3 years. So simple interest is principal times rate times time. So the principal's 1,000. My rate is 6.2%, so 0.06 with a 2. And then times the number of years is 3. So when I multiply that, I get $186. But it's not asking you for the interest. It's asking you for the actual balance. So you need to add 186 to 1,000. And the answer is $1,186. Zipping through this, when we get to number 10, that's going to change. It's going to take me like probably 7 minutes to get through number 10. Okay, number 9. Suppose you invest $250 in an account that pays 4.5% interest compounded quarterly. After 30 months, how much is in your account? So compound, remember the formula for that, A equals P, 1 plus the rate, and then the frequencies N, and then the power is the product of N and T. Okay, the main formulas you got to know from this are simple. The compound formula, that formula that we use to get back to where we started, and then there's a couple more which I'll get to. Okay, so we have $250, 1 plus our rate, 4.5.045. Quarterly is 4 times a year. Now here's the problem, and I use 4 out there. 30 months is not years, okay? You need to divide 30 by 12 to get that to years, and that's 2.5. And then 4 times 2.5 is 10. Okay, so it's 250 times 1 plus 0.045 divided by 4 to the power of 10. $279.59. So that is letter B. Number 10, oh my gosh. This is really the only way I can think of how to do problem 10. Suppose you deposit $15 at the end of each month into a savings account that pays 2.5% interest compounded monthly. After a year, how much money is in the account? Okay, here's the problem. You keep depositing $15 every month. You don't just put money in and leave it. If I just put $15 in and left it, then I'd just go to my formula, but I don't. I keep adding another 15. So after month number 1, I have $15. That's easy enough. Now the fun starts. Now, after the first month, I take 15, and then it's a compound formula, so it's 1 plus our rate, which is 0.025. The frequencies every month, so that's 12. And then our exponent is going to be really nothing, okay? Because it's 12, but think of it, it's every month that I'm figuring this out. So a month is 1/12 of the year. So 1/12. 12 times 1/12 is 1, meaning there would be no exponent. But then after that, I got to add 15. Now what I'm going to do is fill out the rest of the month. So that's going to give me an answer. And then I just repeat the process. 1 plus 0.025 over 12 plus 15. Don't need an exponent, okay? Again, I illustrated why, because 12 months converted to years is 1/12 of a year. Okay, so it's really just 1 year. Okay. All right, so answer. It's going to be month number 4, 1 plus 0.025 over 12 plus 15. Just keep on rolling here with it. 1 plus 0.025 over 12 plus 15. I'm going to punch all this in a second. Where am I at? 1, 2, 3, 4, 5, 6, 7. I got to get 12 months down because it's the whole year. That's 8, 9. The reason I have to do it this way is because that stupid 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 'Cause it's not that I just deposit 15 and leave it. If I did that, it'd be easy. But this one, we keep adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here we go. So $15 is after month 1. Okay, and then I take my 15 and then 1 plus 0.025 divided by 12. Close it, and then at the end of that month, we add another 15. So that's after 2 months. Okay, then what you do is you hit So 15 after month 1, and then after month 2, we just take that times 0.025 divided by 12, and then plus 15. So we're at 2 months. Okay. Then hit times, and then your answer will carry over. And then 1 plus 0.025 divided by 12, close it, and then plus 15. So that's after 3 times 1 plus 0.025 divided by 12, close it, plus 15. That's after 4. 1 plus 0.025 divided by 12 plus 15. That's after 5. It's after 6. It's after 7. That's after 8. After 9. After 10. Fingers don't fail me now. After 11. That's after $1,282.08. Again, the reason why, that's the only way I really know how to do it, when you're adding another 15 yourself every month. See, if I just deposited 15, didn't deposit anymore, I could just go 15, 1 plus 0.025 over 12, and then 12, and then some 1 year. Okay, but I'm not able to do that because I keep adding the 15 on. Problem's over, thank God. Number 11, once we said the most continuously is always most generous, so C. Okay, number 12. The APY, annual percentage yield, is what that's called. Annual percentage yield. I'm going to write that down. That's what APY stands for. Compounded monthly, and it wants to know what that is. Here's the formula to find annual percentage yield. It's 1 plus your rate over the frequency, and then n minus 1, okay? The book starts using m there, but I don't like that, okay? So I just want to stay with what I know. So 1 plus, parentheses 1, 5.9%, so 0.059. And the frequency's monthly, so that's 12, and then 12 out here. Not a product, though, just 12, okay? It's not NT, it's just N, okay? Minus 1, so I punch that into my calculator, so 1 plus 0.059 divided by 12 to the 12th power. And then whoops, I screwed that up. I forgot to minus 1. 1 plus 0.059 divided by 12 to the 12th power minus 1. Okay, they're pretty stupid about how they want percents. You move it twice to the right, and that's 6%, but then they want 0.062. They want 3 non-zero digits, so 6.062%. Okay, number 13, E. You probably maybe seen that in another class. E, actually, we can find our calculator. It's right here. So second E, I'm just going to hit to the first power. And it's irrational because it never ends. Okay, any number that never ends is called irrational. So it's letter A. 14 is another APY problem. Okay, remember the formula. It's 1 plus R over N to the N power minus 1. Okay, so number 14, 5%, but it's daily, so 1 plus 0.05 over 365 to the 365th power minus 1. So 1 plus 0.05 divided by 365 to the power of 365 minus 1. So if I trace it forward, that's going to be 5.13%. Round it off, so 5.13%. Okay, number 15. The value of E is approximately, so I go second, get to E. It's second, and then it's that key right there, 1. So 2.718, it's going to be letter B. 16, when $1,000 is invested at 8% compounded continuously at 5 years, the new balance, now here's your continuous formula. That's like every nanosecond. You take your principal, and that's what they use E for in math. And it's to the power of the product of rate multiplied by time, and the times in years. T's always years. Okay, so we got 1,000 times E. And then the rate is 8%, so 0.08, and then the time is 5, so I find that product, and that's 0.4. Okay, so 1,000 times E to the 0.04 to the 0.4 power, 0.4, 0.4, same thing. And that gives me $1,491.82. Okay, 17, last one, and then we're going on to the exercise. Exponential decay. Now, the back of the book says consumer price index. They use that to see what used cars cost. Used cars are decaying in value, okay, by a percentage. So they say C, but I disagree that it's only C. A is also, because any depreciation is that too. Okay, retirement annuity is not one, because when I put money into a retirement annuity, I want it to go up. It's not going to decay, otherwise I wouldn't put it in there.